All right, we are going to do a problem that deals with this. And the problem runs like this. If 1 gram of sucrose, that's just table sugar, is completely combusted, we'll say completely oxidized, what is the enthalpy change observed? And here I'm going to write the chemical equation for the oxidation. In this case, the oxidation is just the combustion of sucrose. Again, sucrose is just table sugar. And if we combust that in oxygen, that's going to be 12O2. And we're going to get 12CO2 plus 11H2O. And its delta H for this particular reaction is minus 5645 kilojoules. And one other thing that I want to do with this particular reaction is I want to relate it to nutrition. Perhaps you've had a nutrition class, or you've at least heard somewhere that when we're talking about food calories, big C calories, kilocalories, that 1 gram of carbohydrate is going to be 4 food calories. Big C calories, so it's 4 kilocalories. You might have learned this, maybe you haven't. If you haven't, you should know that when you consume 1 gram of carbohydrate, that's going to provide 4 food calories of energy to your body. Protein's a little less than this, but we say that 1 gram of protein provides 4 calories of energy to your body. And fat, it's more than twice as high. 1 gram of fat supplies 9 calories of energy to your body. But we're gonna use this problem to see, okay, we're gonna combust 1 gram of sucrose, which is a carbohydrate. Sucrose is a carbohydrate. And we're going to see if that 1 gram of sucrose, which is a carb, is equal to 4 food calories using this information here. So let's try this. You're going to have to remember, write that in your notes, that 1 gram of carbohydrate is 4 food calories. Okay, so I'm going to start with what's given to me, 1.0 gram of C12H22O11. This equation does not speak to grams. It's like any normal stoichiometry problem. The equation that you see, it doesn't speak to grams, it speaks to moles. So in order to make this 1 gram talk to this equation, I'm going to have to convert my grams of sucrose to moles of sucrose. And if you do that, I'm not going to do it now for you, but you can take the time and do it yourself, you'll find that 342 grams of sucrose is a mole. At this point, this should be easy for you. All right, so let's convert this. 342 grams of sucrose is 1 mole of sucrose. Now, according to this particular chemical equation and associated enthalpy, I see that 5645 kilojoules comes from the combustion of just 1 mole of sucrose. So I know that 1 mole of sucrose, according to the reaction stoichiometry and enthalpy, that should be negative 56.45 kilojoules. And this negative sign, again, represents that when this reaction takes place, energy is released. Where does it get released to? To your body, and then your body can use it to do all sorts of stuff. But let's run this calculation. Let's see. 1 gram divided by 342 times 56.45. That is equal to 16.5 kilojoules of energy for every gram of sucrose that is combusted. Well, what's that in calories? Do you remember the conversion between joules and calories? If not, 4.18 joule is equal to 1 little c calorie. So I'm going to go ahead and I'm going to write this 16.5 kilojoules as 16,500 joules. That's the same thing as 16.5 kilojoules. And then, to convert this to calories, I'm going to put 4.18 joules is equal to 1 little c calorie. So I'm going to take my 16,500, and we're going to divide that by 4.18. And I get 3,947 little c calories, which is 3.9 kilocalories, or roughly 4 food calories in the burning of 1 gram of our carbohydrate, sucrose.